Good evening, students. Today we will discuss about recursive functions. This is a very important topic for output type of questions. So firstly we will discuss what is recursive function. When a function calls itself within its body, then it is said to be a recursive function and the process is known as recursion. Let us see one example. Suppose if any function is there, int fact, int n, if n less or equal to 1, return 1, else return n into fact of n minus 1. See, this is one example of recursive function. The name of the function is fact and it is being called within body. That's why it is a recursive function. Now how it will produce the output? Let us see. Suppose if the value of n is 4, if we want to find the factorial of 4, so the function will be called with the value 4, fact 4. Firstly, 4 is less or equal to 1, condition is false, it will go in else. So this call is broken into another call, 4 into fact of 4 minus 1, that means 3. So we wanted to find the factorial of 4, but we did not get the proper answer. So we have another call, 4 into fact 3. Now we will enter with the value 3. 3 is less or equal to 1, condition is false. Then it will go in as 3 into fact 2. Again, we did not get a proper answer, so we will come with 2. 2 is less or equal to 1, condition is false. It will go in as 2 into fact 1. Okay. This time when you will enter with 1, 1 is less or equal to 1, condition is true. So we will get 1 for the last call. Actually this memory block is known as call stack. When we use a recursive function, a memory block is created, that is known as call stack. And in call stack, all the instructions are executed in LIFO order, last in first order. Okay. So firstly we are getting answer 1 for the factorial 1. Now this will be evaluated with this and that will be the answer of previous call. So 1 into 2, 2 is the answer of previous call. Then 2 into 3, 6 is the answer of previous call, and 6 into 4, that is 24, is the answer of first call. That means this function will finally return 24, that is the factorial of 4. In every recursive function, there is a condition which forces to stop the recursion, that is known as base case. Like this condition is known as base case. Whenever it will go in if, it will stop. And the another one which forces for the recursion is known as recursive case. This is called recursive case. So in every function, recursive function, there should be proper use of base case and recursive case. Otherwise, then recursion also may be infinite, like looping. Okay. Now we have some other output question. Let us solve. Suppose if this is a function and the value of n is 35, how it will evaluate? Octal function, the number is 35. Firstly we are entering with 35. 35 is greater than 7. Condition is true. So it will call, and as you know, when recursive function is called, it will go back to the definition. So another function, octal, 35 by 8, that is 4. Okay. But this line is pending. Why? Because this line is below the recursion. So this line will be executed in the end and in LIFO order. So compiler is not able to resolve this line because from here only the compiler is going back. So we will come with another value. So we can write here something is pending. Now when you will come with 4, 4 is greater than 7. Condition is false. So this time directly it will go to this line, and 4 mod 8. 4 mod 8 is 4 only. And after printing this, it will go to this 35 mod 8, that is 3. So this function will print 43. I think 43 is the octal equivalent of 35. Okay. Now see another function. If this function we want to find the output, the value of c is 4 suppose. So we are entering in the function test 4. is equal to 0 false. Firstly it will print hello and C. That means hello and 4. Okay. Now test minus minus C. Value of C is updated and from here only recursion will take place. That means another function is called with another value, that is test 3. And see, this line is below the recursion. That means this will become pending. So when we are making another call, something is pending which is to be printed. Okay. Now you are coming with 3. 3 is equal to 0. Condition is false. So another output will be there. Hello 3. And the next call will be test minus minus C. That means test 2. And here something is pending. Now with 2 you are entering. Condition is false. Hello 2. And another call is there. Test 1. And something is pending. Okay. When you are entering with 1, again condition is false. Hello 1. Okay. And next call is there. Test 0. And something is pending. Okay. When you are entering with 0, this base case is true. C equal to 0. And it will print a blank line. As you know, as system.out.println blank line. So one line it will leave. And after leaving line, the recursion will stop. And now all the pending instructions will be executed in LIFO order. So you can see here 4 pendings are there. And here, because printing of C is after minus minus C, this time the value of C was 1, minus minus C will be 0. Then here the value of C was 2, it will be 1, 3, that is 2, and 4, that is. So the output will be hello 4, hello 3, hello 2, hello 1, one blank line, and then in reverse order 0, 1, 2, 3. So this way you can find the output of any recursive function. I hope this topic is clear.